I was writing earlier, let's just start somewhere simple. And really you have, this is what it looks like. You just got a place to write text here, and it tells you what it's doing here, right? And then you also hear what it's doing with the sound, of course. But it also tells you what it's doing as it's doing it. If you've got it included today, yeah. And so, the thing with Sonic Pi is I wanted to make it as simple as possible to get started, right? With no barrier to entry. So all we've done so far is launch the app. And then the first thing you can start to do is teach things like sequential programming. So the programming is a sequence of operations. Do this, then do that, then do the other. And so one of the this is like logo really for sound. And so in the same way with logo, you choose where to rotate and where to go forwards. Here we're talking about what notes to play and when to play them. And so you can choose what notes to play by writing the word play. Let's make this a bit bigger. There's shortcuts for everything, but you can also click on the big buttons on the top. I'm going to move my keyboard a bit. So, and then you choose a note. Which note should we play? So this again is where you have a choice. You don't tell them to play note 80. You say choose your own note. So I'm going to play note 90. And then you press the run button. And you hear a sound. And that's the first program. That's Hello World of Sonic Pi. That's how easy it is to get started. And that's actually quite exciting. There's lots of learning opportunities here. You start to talk about data representation. You talk about numbers being able to be abstractions for different things. And what can numbers do? They can go up and they can go down. And what can notes do? Notes can go up and notes can go down. So if we choose a high number, we can get a higher note. Or if we choose a lower number, we get a lower note. Right? That's as simple as it gets. Now you don't need to know what those notes mean. You just need to know that they can go up and go down. You can even choose notes in between, right? So if I want to go for like 70 point, something like this, I can do that as well. So I can play in between notes. But what does in between notes mean? Well, if the children ask and they're interested, then you can start to talk about the fact that these notes are piano notes. And this is the 70th .343, so it's in between the 70th and 71st notes in the piano. If you were to take a piano and write numbers on all the notes, this is note 17 and a bit. And so you start talking about these, you can put pictures up, write pianos and numbers on, you can even get them to play a piano or write numbers on a piano. There's all these different things you could do, and that's just with one line of code. And then you can start to think about melodies, right? So I want to play one note, then another note. And so if I play two notes like this, something quite interesting happens. It plays them at the same time, right? Because the computer's so crazy fast. Computers are crazy fast. They'll do this one, then that one. So quickly, it sounds like they're playing at the same time. So it actually tells you that it's doing them at the same time here. It's grouping them together. And so if you want to make a melody, you can't do this. This is how you make chords. If you want to make a melody, you have to put some time in between. You put some time in between by writing the word sleep. So if I sleep for half a second, like this, over the melody, right? And that's it. This is, once you've got these two things, this is where I sort of get frustrated with the musician people who talk about this dots on the stave being the most important thing. This is most of the dots on the stave with these two commands. I can take Bach and I can render it with those two commands. It's amazing, right? Because all it is about when to play notes and what pitch to play them. That's those two commands there. There's more stuff in Western notation, and I can show you how you can implement those things with code, and I can show you even how code goes radically further than you can do in notation. But this is most of Western notation already with two commands. And then in a class, you can just give the kids these tools and just say, play. And they will, right, place it, just for hours, right? And they'll have a lot of fun. And then you walk around, and some students are happy with that, and some are saying, well, I'm a bit bored of the beep sound. Does it do more than a beep sound? Well, yes. So you just tell the individuals who are interested how to change the sound. So I change it by saying use synth, switch to a different synth, and I have a different choice of synths. So what should we go for? Let's go for Prophet. It'll sound different. Prophet actually sounds better on a lower note. Let's go for 50. And so you can start playing with these things. So you can just slip in these use synths any way you want. It will just change the current sound. It's just having a keyboard having the current sound. And now, at this point, we're into computing territory, right? Because the kids then will have written maybe a really long thing, and then maybe they want to do things a few times. I want to do this 5 times. This is where computing really becomes very powerful, because I can say things like, okay, I'm going to do that 5 times. Well, actually, I'll leave that out. It'll be quite fun. Let's write 5 times, do. And then where I want to finish the thing, I want to do 5 times right end. And off I go. And actually something interesting happened there, probably not what you expected, in that you heard notes being played at the same time. Here's again a learning opportunity, because you can talk about the fact we played note 70, we waited for half a second, we played note 50, and then without waiting anything we played 70 again. Because it's a circle, this 50 and the 70 are actually the same time. And we can even see that in the log on the right hand side here. You can actually see that the first note was played on its own, and then here we have pairs of notes, and then a single note. So this is great, I think, for showing children, inviting them to play sounds, and when they question what's going on, listen to what's happening, and then look at what it's doing, and it tells you exactly what it's doing and what times they are. So if we want them to play separately, we need to add another sleep in there. So let's go for sleep for 1/8 of a second. We'll start playing with this, right? And then we're having a good time. And we can see now that we're playing these notes one after another. Notice though that this programming language is not Python, but it's very, very similar to Python. But one of the things I think, this is a language called Ruby. One of the benefits I think of Ruby is it allows you to write messy code. Right? I think that's really important to be allowed to write messy code, because then you can learn what not messy code is. And you're not forced into this thing where you have to write in a particular way, because that's just annoying. I don't want to write, I don't want to be told what to do, I want to be able to be messy. And so in Python you'd have to indent all these things or it just wouldn't work. And in Ruby you don't have to indent them. But if you want to, you can just press this button which magically does it for you. So if you want neat code, there's a button for it, which is nice, right? And that's really useful as a debugging tool. And so once you've got this, then you can start talking about loops, right? So I can make this will go forever. And then the cool thing is, it's just going to go forever. I built this thing which, because I also want to use it as my own musical instrument, I want to perform with this thing. This is good enough for the curriculum, right, in terms of loops, but it's not good enough as a musical instrument. And one of the things I want to with Sonic Pi is to not just be something you can use to teach the curriculum stuff, but also have a bunch of tools and gadgets and gizmos in there that you can just engage kids with. So if they get a bit bored, you throw them a cool thing that doesn't necessarily tick a box in the curriculum, but gets them excited, so they're going to carry on doing the curriculum stuff, right? And so loops aren't that great, but what's really great is a live loop. It's awesome. Give it a name, what I call it, foo. We call things like foo bar in computer science, right? And it's just going to do the same thing, right? It's looping, but it means I can change it right on the fly. So if I change this time to 1 second, it's just changing the pace, right? So I don't like that. Maybe I want to change this note to have a different cutoff value, or maybe 17. Maybe I don't like that note at all, actually. Maybe I just want to do that. I'm starting to build something up, right? Maybe what does cutoff mean? I don't really know. I could read the docs, there's documentation, so I can click on that and read about it. So I can click on help, I can go down to the synths, I can click on the profit synth, find it here. I can see all the different options, and one of them is cutoff. Let's find cutoff. Here, click on that, and it tells me what it is, right? So MIDI note representing the highest frequencies are like, but that doesn't mean anything to me. So what I'm just going to do is I'm just going to change a number and see what happens, right? And then I can learn what it does by, let's change the sound of it, right? That's quite nice. Right, so I can change the sound of the sound by changing the numbers. I'm just playing around. So I can read it if I want to, but I could also just play. And then I can, so maybe I want to last for 8 times and take 8 seconds to play the note. So now I've got something slightly different. I haven't stopped the code yet, it's still running from that original thing I wrote. Right? And the other thing that kids want to know all the time, it's not in the curriculum, but we do have it as part of the Key Stage 3 syllabus, is threading, multiple threads, things happening at once. This is really, really useful in music, because I've got this going, but I want to get some drums in the background, because I'm a bit bored of this, I need to do some dancing, right? So, how do I get some drums? Well, I create another live loop, which is another thread of execution, I'm going to call it drums, and I'm going to synchronize it with foo, so they're working at the same time. This is a special tool that you can use, and then I'm just going to play a sample. There's going to be a bass drum house, and I'm going to end here. So we've now got 2 things happening at once, but they're completely in time synchronization. So what this sync says It says wait for foo to repeat, and when you repeat, play me. So that's why the drums are being played at the same time as the prophet sound. But once they're synced, you can unsync them, and then you need to put some sleep in here, so sleep for half a second. And now we're going to get a drum rhythm going, two things at the same time. Right, and that's quite nice, that's quite simple. And I can play around, and again, I can sort of maybe change the cutoff for this. So bring this in. Right, and I'm writing code here, and the code is changing the sounds as I'm messing around with it. Now, the cool thing is that the concept I'm showing you here, I've taught to primary schools in a day, right? It might look alien to you, but it's actually really, really simple. And then we get something else going, right? We can do some randomization. Let's make let's call it vortex. Why not? And we're going to sync with foo, and we're going to what we do is we can take some notes, and we're going to take notes from scale E3 minor. There's all these different scales built in, right? You don't need to know what these things mean, but this is a list of numbers. I'm going to play one of those notes, choose the notes. And I'm going to sleep for 0.25 seconds. And I'm going to make it short, this release time. All these things, you might not know what they work, there's documentation to describe all these things. So let's get that synced. So that's sounding okay, but it's not that great, is it really? So how do I make it a bit better? Oh, if I make it go a bit faster, I'll make it better. And then maybe, we saw we could change the synths, right? Well, the prophet was quite nice. So it's starting a bit better, right? But it's a bit too annoying, so I wanted to change it. So we saw we could change the cutoff value. When we cutoff value changes, that's actually quite nice. I quite like that. But it's a bit boring to have to keep doing this manually, changing this 100, right? So I want the computer to do it for me. So I'm just going to randomly choose a note between 70 and 120. Right, we're off, right? We're doing it. And we can now start to do even cooler things. So we're going to do this 16 times. Right? It's just working like this. But I can start to add effects. Maybe some, maybe echo. Around. Right, I just added an echo effect. I can change the phase time. I can get rid of it all now. Syntax is right. And off we're going, right? So I'm exploring these concepts, and the cool thing is that when a child says, how do I do this? Then the answer is always computer science. You know, it's like it's loops, or it's functions, or it's question, yes. Do I have any human voice sounds? Well, so, no, actually I don't. But you can, so we saw before you can do samples, right? We have 70 different built-in samples. They're all Creative Commons Zero license, so you're free to use them to make money out of this stuff if you want to make a track on top of the pops. So you can use all the built-in samples. So there's a choir sound, sort of voice-like, a bit like that. Yeah, so you can do some fun stuff with that, like live loop that guy. Oh, I've switched around the windows. And sleep for 1.25, well, this will do. Style, right? You can play around with it. So you can start to do that, but because it supports samples, you can just record your own samples. So you can just take a tape recorder or iPhone or whatever, record the sound of trees or the sound of like an explosion or whatever you want to record, or headmistress screaming down the corridor, and then play that with reverb backwards, right? You can do that. And how long have I got, by the way? How much time have I got? I'm still